Assalamu alaikum guys, how are you guys doing? I hope doing well. Welcome to Probability and Statistics, lecture number 1. Uh, First of all, let me introduce you to the books of this course which we are using. The right side is Walpole, Probability and Statistics, and on the left side this is from Niall A. Wise. This Walpole's book I will be using the most, but you can use this as a reference book, the other one. So first of all, let us ask ourselves a question. What is statistics? So statistics deals with collection, analysis, interpretation and representation of the data. Okay? Collection of the data, how we collect the data, how to analyze that, how to interpret that, and how to present. These are the four main things. And what is the data? Data is basically a raw material for the statistician, right? The number we use to interpret reality. Basically, data is a number, right? Let's say if we talk about age of people or height of the people, so we have to give some numbers to them, right? The weight is 70 kgs or pounds, right? Similarly, height and age and stuff like that. So we associate numbers with them, but they give you reality, right? So whatever data you collect, you have to play with it now, right? So the first thing is how you collect data. So you have to be systematic about that. Once you get the data, you have to do some analysis on them, and then when you did the analysis, you got the results, then how you interpret the results, what the results are showing. Okay, and you got everything. Now you have to present your data to the others so that they can also understand. You can present it graphically or in tabular form or whatever, right? So we will be dealing with all these things in this course. Who uses statistics? A market analyst wants to know the effectiveness of a new diet. This is one of the examples. Okay. Second example is a pharmaceutical company. Pharmaceutical company is the one who manufacture or make medicines, right? So they want to know if a new drug or a new medicine is superior to already existing medicines, right? Let's say they are launching a new drug, so they want to collect the data and see whether it is more effective or not. So this is a problem for statisticians. How fuel efficient a certain car model is. You see, we every day we want to know about these things, that if I'm going to buy a car, I'm concerned about the fuel efficiency of the car as well, right? Similarly, is there any relationship between your GPA and employment opportunities? Let's say if you get a better GPA, do you think that it will create more opportunities for you, or any GPA will work out for you, right? So is there any relationship between these two things? So these are all examples of statisticians. Two types of statistics. One is descriptive statistics and another is inferential statistics. Okay. In descriptive statistics, we summarize and describe important features of data. Okay. Numerical summary of measures, for example, mean, median, standard deviation, etc. Similarly, graphic or visual display, histogram, scatter plot, etc. Okay. So we will go through all these things, of course, in this course. Inferential statistics consist of methods of drawing conclusions about a population based on information obtained from a sample of a population. What is population and sample? If you are discussing something, the totality of that, the whole thing is your population. This population is not a population of a country or something. It can be anything. For example, if you talk about students of the University of Boremi, then all the students of University of Boremi are your population. Okay. If you are just talking about students of College of Engineering only, then only the students from this college are your population. Then you will not include business or law students in your population. Okay, so population is the totality of your interest, and a sample is a chosen portion of the population. Let's say from all UOB students, you pick 10, 15, 20 students, let's say. Then those 10, 20 students will be a sample from your population. Okay. Common types of inferential statistics are confidence intervals and significance tests. Okay. So these are two main types of statistics. Population versus sample, as I told you, population is the whole thing, right? And if you pick some out of them, it's a sample. Okay, so sample has to be a subset of the population. It can be as large as population itself as well, but usually it is smaller than population. What is a variable? A variable is a characteristic that varies from one person or one thing to another. Okay, so like in mathematics, any quantity that keeps on changing, we call it a variable, right? So here as well, if some characteristic which changes from person to person, for example, if we are talking about age of the people, age varies from person to person, right? If we are talking about the weight of certain things, then weight will change from one thing to another, right? Height, your GPA, whatever, these are all called variables. Okay, for example, in case of humans, height, weight and number of siblings, they are all changing, so these are variables. Sex, marital status and eye color, they also change from one person to other. One person is a male, second is female, so they are changing by sex. Marital status, one is married, another is unmarried. Similarly, your eye colors are different as well. So these are all variables. But in these variables, we also have two different types of variables: quantitative variables and qualitative variables. In quantitative variable, we get the quantity. For example, the height has a quantity, weight has a quantity, number of siblings have quantity. But sex, marital status and eye color do not have any quantity. These are the attributes related to a person. These are the qualities. That's why we call it a qualitative variable. Okay. So in quantitative variable, there are further two types of variables. Not in quantitative. This is quantitative, which has quantity, numbers. Okay. So discrete variable and continuous variable. A quantitative variable whose possible values can be listed. If we can list possible values, then it will be a discrete variable. Okay. Usually these are whole numbers, 1 2 3 4 5 6, like that. Okay, but in continuous variable we cannot list all the all the values. So what, instead we have intervals. We can say that okay, this variable may lie between 10 and 15, but we cannot list all the values because between 10 and 15 there are infinite many real numbers. Okay, so usually continuous random variable get the values in the fractions inside the intervals. So from a variable, we got two type of variables, qualitative and quantitative. Then quantitative variable further has two categories, discrete and continuous. Okay. Variable versus data. Variable is one thing, right? But if you collect the values of the variable, we call it a data. For example, if I say that the GPA of the students in College of Engineering, this is my variable. GPA is a variable. But if I start writing the GPAs of all the students, then it will create a data. 3.16, 3.14, 2.79, 4, 3.9, and so on, right? So what I'm doing now, I'm creating data. So data are the values of the variable. Similarly, if I'm collecting the data from a qualitative variable, I will call it qualitative data. If I'm collecting the data from a quantitative variable, I will call it quantitative data. If I'm collecting the values from a discrete variable, it will be called discrete data, and similarly the continuous data, right? So depends which variable you are using. We can call data according to that name. A marathon race, the classification of each entrant as either male or female. Let's say someone is participating in a race. Marathon race is a very long race, like usually 5 to 10 kilometers. So if we are only categorizing the participants as male or female, then I cannot say he's 10 male, he's 12 male, he's 17 female, right? A entrant can be either a male or a female. That's it. We cannot associate a number with it. So this will be a qualitative variable because we are only categorizing them as male and female. Only the quality of an entrant. Similarly, if we determine the place of finish, let's say if every entrant is placed is recognized as the place he is finishing in, for example first, second, third and so on, then it will become quantitative discrete data because now is first, second, third, 1 2 3, we are listing their position, right? So it's a quantitative data, and because we are listing, doesn't matter if there are hundreds and thousands of participants, I can list all of them, right? That he came in first position, he came in second, he came in 10th position, 20th position. So it is quantitative discrete variable. But now if we are writing the finishing time, sorry, with every entrant, if I am writing what is the time he is finishing, he took 2 hours and 8 minutes 42 seconds, 2 hours 32 minutes 16 seconds. Now you see these are in the fractions, these are in the points. So these variables are coming in the intervals. We cannot list all the values, right? Because they can come in any form. They are not whole numbers. They are not 1 2 3 4 5 6. So whenever something comes in fractions, in points, we call it a continuous variable. Okay, so this is quantitative but continuous variable. Now if I write these examples, human blood types AB, AB positive, AB negative, O positive, O negative, right? These are all qualitative data. Similarly, household size. In one household, there are 3% living. So I can call it 3. If only a single person is living in a house, it's 1, right? And so on. But this is a discrete data because number household cannot be 3.5. Either there will be 3 people or there will be 4 people. There cannot be 3.5 people in a household, right? So it is a discrete data. But height of the mountains, 3425.023 meters. So see, again it's in the fractions. Whatever comes in a fraction, in a points, continuous data. Okay, so we have qualitative, quantitative discrete and quantitative continuous variable. So now as an activity, you can write down various examples of each type of the data that we just discussed. So whatever comes in your mind, try to write a qualitative example, discrete and continuous random variables example. Okay, so this was the first introductory lecture, so I'm stopping here. I will continue with more stuff on statistics in the next lecture. So till then, bye from me. Assalam.